In our previous video, we proved this theorem using the geometric series. Today, we will be proving it using algebraic division. If you remember the remainder theorem that we learned before, it says that the remainder of a function fx when divided by x minus a is fa. So here, fx is our dividend, that is fx equals x to the power n minus a to the power n. So here fa will be equal to a to the power n minus a to the power n. So this gives us 0. So this means that there is no remainder when x to the power n minus a to the power n is divided by x minus a. Now let's get into our division. So here we have x to the power n minus a to the power n divided by x minus a. So when we divide, many students think that this a to the power n is the second term here. In fact, a to the power n here is our last term. That means it is our nth term. So we write it at the end, meaning the rest in between are 0. So our first step will be to remove this x to the power n. So to remove this x to the power n, we need to subtract it by x to the power n. So to get this x to the power n, what will our quotient be? So for this, we divide x to the power n by this x. So x to the power n divided by x will give us x to the power n minus 1. So that will be our quotient value, x to the power n minus 1. So now x to the power n minus x to the power n will give us 0. So next we multiply this minus a into x to the power n minus 1. So this will give us minus a into x to the power n minus 1. Now we subtract 0 by this value. So 0 minus ax to the power n minus 1 will give us positive a into x to the power n minus 1. So to check what we have done correct here, we again multiply and see. So x into x to the power n minus 1 will give us x to the power n minus 1 plus 1. So that is x to the power n. So here we have got our x to the power n. Similarly, this is also correct. So now we can go to our second step. So now our second step will be to remove this ax to the power n minus 1. So for that, we need to subtract it by ax to the power n minus 1. So what should the quotient value be here to get this value? So for that, we take this ax to the power n minus 1 and divide it by this x value. So that will be equal to ax to the power n minus 2. So this is our quotient value. Now that we got this, then we multiply minus a with ax to the power n minus 2. So that will be minus a squared into x to the power n minus 2. So here we will have 0. So 0 minus a squared into x to the power n minus 2 will be plus a squared into x to the power n minus 2. So here this and this will cancel off and only this a squared into x to the power n minus 2 will remain. So our next step will be to cancel off this a squared into x to the power n minus 2. So for this, we divide this a squared into x to the power n minus 2 by this x, giving us a squared into x to the power n minus 3. So basically the same process will go for n number of terms. Now let's analyze this quotient here. So here we can see that the power of x reduces 1 by 1 in the consecutive term. So here the first term we have x to the power n minus 1. So the next one we have x to the power n minus 2. The third term we have x to the power n minus 3. So the nth term will have x to the power n minus n. That means x to the power 0, which will be 1. Similarly, when we analyze the power of a, we can see that the power of a increases by 1 in the next term. So here we have a to the power 0, that is 1. So here we have a to the power 1, the second term. Then the third term will be a to the power 2. So the nth term will be a to the power n minus 1. So now when we do this long division, our nth term will have the final remainder as 0. How do we know that this is 0? We proved it in the beginning of our video here, that when we divide x to the power n minus a to the power n by x minus a, we get the remainder as 0. So now let's look into our theorem. So here we have limit of x to the power n minus a to the power n divided by x minus a as x tends to a. So instead of this function, we write our quotient here. So that would be limit of x to the power n minus 1 plus a into x to the power n minus 2, similarly until we go for n number of terms as x tends to a. Now we use our direct substitution here. So when we use our direct substitution, we get a to the power n minus 1 plus a into a to the power n minus 2 plus a squared into a to the power n minus 3 until we go for n number of terms. So finally we get a to the power n minus 1 plus a to the power n minus 1. So all the terms will have a to the power n minus 1. So this will continue for n number of terms. That means we have n into a to the power n minus 1. So finally we get the answer that we want. So this proves that the limit of x to the power n minus a to the power n divided by x minus a as x tends to a gives us n into a to the power n minus 1. So that is the proof of this theorem using algebraic division. In our next video, we will show that this theorem is true even for negative values of n. Comment down below if you have any questions regarding this. Until we meet again, take care.